All right, so in 1.6 we talked about inverses. We talked about how to figure out something was an inverse 3 ways. One was from points, and then from a graph, and then from an equation. So how do I know if it doesn't have an inverse from points? What are you looking for? What would make it not have an inverse if you're looking at the points?
If there were two the same x or y.
Good. So if it's not for a function, same x can't repeat with different y. To have an inverse, the same y can't repeat for next, right? Yep, good. How about from a graph? What's the test to use to see if it's one-to-one or has an inverse? Horizontal. How about from an equation?
Absolute value or x to the positive power.
Good. To an even power. Good. Yeah. X can't be in absolute value or even power. Okay, so these are the ones that are quick and easy, right? So if you know all that information, then 1 is yes or no? No. 2 is no. 3 is 4 is, and 5 is? Good. And then to find the inverse, step 1 is replace the f of x with y. Then switch the x and the y. And then solve for the new y. Divided by 2. And then the last step is switch that y back out for the f -1 of x. So we're showing that this is no longer f. We have changed it. And what this is the inverse of f. Yep.
Could you just leave it as like all of x minus 5 over 2?
Yeah. I mean, if you went to graph that, you'd have to separate it out. That would be the only benefit of separating it out. But if you left it as x minus 5 over 2, it's okay. As long as there was nothing that was able to be simplified. Yeah. And if it was a standardized or multiple choice test, which this one's not, but let's say midterm, that kind of stuff, it would separate it probably. Any other questions on the warm-up? Okay. All right, so we're going to graph the equation, right? So I'm going to graph that first one, which was, and somebody will help me out with it. This is the 1 over the x plus 1? Yeah, right? So I'm going to open the parentheses. I'm going to do 1, oops, that's not a 1, that's a 0. 1 divided by, open the parentheses for the denominator, and it's x plus 1, right? And then close my parentheses. And then for the restriction, I open the parentheses again. And I enter the restriction, which is what? X has to be greater than or equal to 0. So I do x. My greater than or equal to is above the math button under test. So I go to second, test. I go to greater than or equal to. And I put in the 0. And I close the parentheses. And I hit enter. And if I graph that now, you'll see this like blue horizontal line. If you have the colorful one, you'll see a blue horizontal line where it's restricted, and then the actual graph where it's not. If you don't have the color one, you'll just see the graph sort of like raised like that. Okay, Maria. All right, so then for the second one, All right, so 24. The second part was find g of f of x. So the g was the 1 over x plus 1, right? And then the f of x is 1 minus x over x. I'm going to take this and plug it. Wait, is that the right one?
Yeah, it's just 1 plus x.
This is your f of x, right? So this one's going in here? Okay. So I'm doing 1 minus 1 over x plus 1 over 1 over x plus 1. So I've got a complex fraction. I've got fractions within a fraction. Super fun stuff, right? So I have to change the numerator so that it's one same denominator, which means on the left-hand side I have to make that x plus 1 over x plus 1. And then combine that into one fraction. So it would be x plus 1 minus 1 over x plus 1. All of that was over 1 over x plus 1. And then from there I can simplify it as x over, because the positive 1, negative 1 cancels out, x plus 1 over 1 over x plus 1. And then a fraction divided by a fraction, I'm going to keep change flip. So dividing by this is the same thing as multiplying by this. And then these cancel, and I end up with x over 1, which is just x. So you're dealing with complex fractions. Okay, Jim. So then the other way around is taking this and plugging it in there, right? So 1 over 1 minus x over x plus 1. Now the fraction's in the denominator, right? So I've got to change the 1 in the denominator so that it's something over x, which would be x over x. The 1 in the top stays. The bottom would become 1 minus x plus x all over x. The negative x and the positive x cancel out. I get 1 over x. And then keep change flip again. Dividing by 1 over x is the same thing as multiplying by x over 1. And then 1 times x over 1 is just x. All right, so this is great piecewise practice, right? The first thing, I mean, you can kind of evaluate where it should be and then narrow down your points if you use your transformations. The minus 2 and it being cubed, so the cubic function is the one that looks like this, right? Well, it's really rough, but it looks something like that. And it would have been shifted to the right 2 places. So I at least know it would look something like this, and then I would restrict it. But because that's not restricted like from 2, it's restricted from 3, I want to make sure I plot an extra point. So I would actually plug in 3. So 3 minus 2 squared is, or cubed, is 1 cubed, which is 1. So now I know that this graph would start at 3, 1, and it would have an open dot because it's not or equal to. I know it would hit 0 here where that 2 is because of the shift right 2 places. And then I would like plug in 1 and see what happens. So if I plug in 1, so at least I get those 3 points, I get negative 1 cubed, and negative 1 cubed is negative 1. So I know my cubic function would look something like that. That's the left side of it, right? And then the parabola is 4 places to the right. So I know my parabola would look something like this. But again, those aren't exact points with the exception of the vertex. So I need to know what happens at 3. I plug in 3. 3 minus 4 is negative 1. Negative 1 squared is a positive 1, which means this gets a solid dot. That's going to get filled in. And then it would come down to my vertex. If I plug in 5, 5 minus 4 is 1. 1 squared is 1. And I know my parabola would continue up on that. So this little shape on the inside is kind of funky, right? Because it goes up and then it comes back down. So it is a function, but that's not one-to-one, right? It would fail that horizontal line test. So there would be no inverse there.
Where'd you put the extra points that aren't at the open circle, closed circle? Is that just to plot the points?
Yeah.
Okay.
Yeah, you want to be able, because you want to be exact enough to be able to figure out where that curve is. You need to, if it's not obvious from your vertex or from your shift, I would plug in those points so that you know exactly what happens. And remember, if it's like a less than, not a less than or equal to, it's going to get an open dot. You still need to know what that point is. It would have gotten the open dot. Because let's say that parabola shifted to the right 5 places. I would have had an open dot that was blue and then a red dot above it that went on my parabola. And you need to make sure that you know what's happening at that blue dot too. Does that make sense? So even though it's not included in it, you need to plot it so you can figure out where the open dot goes, basically. Sometimes they fill in and sometimes they don't. You got to make sure you know what they look like. All right, we good? Isabella? And 2-1 is all about quadratics. So we've narrowed everything down to parabolas. We're going to exhaust a conversation on parabolas, okay? We're talking about how to graph them. There's a bunch of different ways, how you change them from one form to another, okay? And then all the information that you can get from them. So the good news is this is good review for graphing. Like, it's going to help you with the parabolas and that kind of stuff, okay? But we're not going to go in depth on the test. This will be on your next test, okay? Like the one after Tuesdays. All right, so a quadratic function is one in which the x is squared. This is called quadratic form. So when you see an x squared and an x, it's called quadratic form. What we've been using for transformations is called standard form. You'll see that in a minute. But this is called quadratic form. So the ax squared plus bx plus c is quadratic form. The shape is called a parabola. It's shaped like a U. And it's symmetric to a line called the axis of symmetry. So this is quadratic form. If it has an x squared and an x. All right, the graphs of them, and we've seen a bunch of them. The point in which they change direction, so if they open up and they open down, the point in which they change direction is called the vertex. If it's opening down, that point is also a maximum, and this is going to be an absolute maximum because there's only going to be one. And then the point in which it goes down and comes back up, that vertex is called your minimum. And the line, which is a vertical line running directly through your vertex, is the axis of symmetry. Because it's a vertical line, when you name it with an equation, and it will be an x equals whatever the x coordinate of your vertex is. But it's always going to be an x equals a number because that's a vertical line, okay? You can't just give me a number like 3. You have to write it as the equation, which is x equals 3 or whatever it is. If the a is greater than 0, then your parabola opens upward. If the a is less than 0, then it opens downward. So positive opens up, negative opens down. All right, so using what we know about transformations, right, and about plotting points, let's graph this. We're going to graph it by plotting points. So do it like, you know, this is an education. Like now you know more information about these things, right, than just plotting random points. So what can you tell me about this parabola before you graph it?
It's stretched and it goes one to the left.
Good. Vertically stretched and one to the left. So I know approximately it would do something like that, okay? So from here on out, that's not enough, right? I've got to keep going. I've got to have at least 3 points. I need a vertex. I need a point to the right and a point to the left, okay? That's minimum. So, but use your transformations to help you figure out what that vertex is, right? So I know that the center point is -1, 0, right? We know that point's -1, 0. Plug in a point to the left of it. So what's a number that's left of -1? -2. And a point to the right of -1, like 0. Go ahead, make it easy on yourself, right? So if I plug in -2, I get 2 times -2 plus 1, jeez Louise, squared. And I get 2 times -1 squared, which is 1, equals 2. And then do the same thing with 0. 2 times 0 plus 1. And if you space them out evenly, so if I want one left and one right, then there should be a reflection, right? These quadratics are symmetric. So there should be a reflection, which means if the left point was one space left and I went up to 2, then my right point, which also went 1 point over to the right, should also be at 2. So I've got negative 2, 2, negative 1, 0, and 0, 2. And then I plot my points. Sorry.
So, if you find one of the points, can you just, since you know that it's like 1 right and 2 up, can you just do that?
So the only reason I would recommend checking it is if you found the first one wrong, you're now finding the second one wrong too. So test-wise, I would plug in the extra point. But certainly, like when you're practicing and that kind of stuff, if you're careful, then yes. If you've gone up and to the left, like the 2, then you're good on the right-hand side. Yeah, they should always reflect. But if you mess up that first point, you're going to mess up the second point too. So just be careful.
Is it the 2 before it, just the slope of it that you go up?
With a line, an absolute value, it's your slope. But with a parabola, because it's quadratic, it changes. So it goes up exponentially. So I'm going up 2, but the next time I'm going to end up going up 4. And then the next time I'm going to end up going 16 because it's going, does that make sense? Yeah. So with absolute value, because absolute value is like a line on either side. And a line, slope is linear. But the rest of them, if it's squared, it's going to go up squared. If it's cubed, it's going to go up cubed. All right, so now, here's what we just did basically. We took something that was in standard form. So standard form is the one that we've been doing with transformations. The A on the front, again, told us if it opened up or down, if it was stretched vertically. The X minus H on the inside is my horizontal shift. The plus K on the outside was my vertical shift. So from the equation, you should be able to identify the vertex without having to graph it. The vertex is the opposite of what follows X. And then whatever's on the outside, whatever that K is, the sign stays true. And then your line of symmetry is just X equals H. So whatever X, the coordinate you get for your vertex is what you would set X equal to for your line of symmetry. All right, so now that we have it in standard form, because eventually we're going to go into quadratic form. To graph using standard form, we're going to look at it first, determine if it opens upward or downward. So we look at the A, is it positive or negative? Okay, find the vertex. You can either use your equation or you can shift it and find it. Find any intercepts. So this is good practice because you're going to have to do this on your test, right? Find your intercepts. The x-intercept, you plug 0 in for y. The y-intercept, you plug 0 in for x. And then plot the intercepts in the vertex. And if that's not enough information, then you need to plot extra points. All right, so let's put it all together. So from the beginning, what do I know about this equation? Which way does it face? Down. So I know parabola is going to face downward. What's my vertex? Negative 2, 4. Opposite of what's inside with the H, and then the same as what's on the outside. What's my axis of symmetry? X equals negative 2, right? You got to give me that equation. So I've got those two already. Negative 2, 4, there's my vertex. That's also my axis. Now find the intercepts. So y-intercept is y equals negative 0 plus 2 squared plus 4. Negative 2 squared plus 4 means square the 2 first and then take the negative. So this is negative 4 plus 4, which is 0. Now I've got another point. My x-intercept, which I already know one of them is 0, 0, but there might be another one. So now I say 0 equals negative x plus 2 squared plus 4. Subtract the 4. Multiply by negative 1 on both sides. Square root both sides, but I got to put the plus and minus in the front. And and I get that x plus 2 equals a positive 2 and also a negative 2. So I get x equals 0 and x equals negative 4. And now I've got a third point, negative 4, 0. So I have enough information to graph it without having to plot any additional points. If I didn't have intercepts, okay, if I didn't have 3 points, then I would plot additional points. What's the domain on this function? Negative infinity to positive infinity. Is there ever a restriction on something you can square? Can I square a negative number? Yeah. Can I square 0? Yeah. Can I square a positive number? Can I square a fraction? Is there ever a restriction on squaring? No. So domain will always be negative infinity to positive infinity on parabolas that are functions, right? That open up or down. How about range? What's the range on this one? What's the y coordinate of your vertex, right? Because that's the highest point. Does it get a bracket or a parentheses? Bracket. Okay. Just for practice, like you could do increasing and decreasing on this, right? It's increasing from negative infinity to negative 2, and then with a parentheses, and then decreasing from negative 2 to positive infinity. Everybody good on that? Yep, the max there would be at negative 2, 4. There's only one absolute max. Okay. So all the information that we talked about before can apply. Is this function, is it symmetric to the y-axis? Is it even? No. Is it odd? Symmetric to the origin? No. Right? Not symmetric to the x-axis, not symmetric to the y-axis. It is symmetric along the axis of symmetry, so don't confuse those two, right? It's symmetric along the x equals negative 2, but not symmetric to the y-axis. Here's another example for graphing in standard form. So the first thing I would identify is that this is a parabola that opens upward because it's positive a. And then the vertex would be the opposite of what follows x, which is 3, and then the k, which is negative 4, which makes your axis of symmetry x equals 3. So 3, negative 4 means my vertex is here. And then to find the, I would plug 0 in for x, so y equals 0 minus 3 squared minus 4. Negative 3 squared minus 4, which is 9 minus 4, which is 5. So 0, 5 means I've got an intercept there. And then the x-intercepts, 0 equals x minus 3 squared minus 4. Add the 4 to the other side. Square root both sides. So I'd get a positive 2 equals x minus 3 and a negative 2 equals x minus 3. Add the 3, I get x equals 5. Add the 3, I get x equals positive 1. So 5, 0, and 1, 0. Here and here. And I've got enough information to draw my parabola. All right, we're going to continue with the rest of 2.1 tomorrow.